What's up, everybody? Welcome back to another live stream from the Scalar Learning Channel, and we are 2 days away from the big day, the big test that is on Saturday. And for everybody who wants to know, tomorrow we are doing a huge video. That is, we're going to be doing a long review session. I'm going to start early in the morning in California. The reason why I do that is so everybody can have a chance to jump on this final live stream. It's going to be a cumulative review, so we're going to go through all the important formulas. We're going to go through important topics, tips, all that stuff. One giant final review. I've been doing these every time before the day before the test. People have been finding them really helpful, really useful. So we're going to do the same thing tomorrow morning. I'm thinking we're going to start somewhere around 8 a.m. PST, but that is TBD, to be determined. But as soon as I know, I'm going to post it, and you guys are all welcome to join. I see somebody's up in Turkey at 1:15 a.m. Abdullah. So merhaba, nasılsın? I know a little Turkish, and that's about it. Well, a little bit more, but I see some other folks. Yep, Hannah, what's up? Dammy, yep, it's live. Okay, here we go. So we're doing the hardest questions from 2022, stepping through official test questions. This is also going to help show some of the trends. And this first question is a great example of some of the trends on recent SATs. More geometry, what are sufficient to prove two triangles are congruent. So it's important to note on this question, there's several theorems that you want to know for triangle congruency. It's side, angle, side, side, hypotenuse, leg, and angle, side. These are the five golden ones. So check this out. What's up from Nigeria? Yeah, all right. So we've got, right now we know that two angles are congruent, but guess what? For congruency, we need more than just angles. And by the way, when two angles are congruent, we know the third angles are congruent. Why? Because this is 70. These have to be 110, right? That's the triangle sum theorem. But it doesn't matter. So another angle is not going to help us. We need a side. And by the way, any side that we know, where we know that are congruent, any pairs of sides that are congruent, we're good. But they have to be corresponding sides. So check this out. This is an angle, and of course, this is probably not the right answer. So we say BC and EF. Let's look at this first, BC and EF. If those two are equal, they would be corresponding because they're both opposite the same measure angle. So BC and EF would be enough to prove by angle, side, angle. Again, it has to be in that order. Conversely, AC and DE, right? Here's AC, here's DE. That wouldn't help because they're not opposite congruent angles, meaning they're not corresponding, so C would not win. Boom, done. Number 10. All right, this is a nice rational exponent rule. So with rational exponents, we got a couple of things here that are going on that I want to explain. First, these guys, when it's outside floating like that, they multiply. So I have y to the 1/8 times y to the 3 times 3 is 9, 4 times 2 is 8. Now we have a situation where we're multiplying two of these terms, and when we do that, we add the exponents. So 1/8 plus 9/8 is 10/8. And then I can reduce that fraction just like any other fraction, make it 5/4. And then what did they do? They rewrote it, as they often do, in radical format. So what is that? That is the bottom number is the root, the fourth root, and the top number is the exponent, y to the 5th power. Fourth root, y to the 5th power, a is the winner, done. We could have also written this as the fourth root of y and the entire thing to the 5th power. These are equivalent, identical, so that's that. Number 12. What is the graph of this one? So it's an exponential, and it's got this weird transformation. I chose this problem because I know it could be confusing for a lot of people, but there's an amazing way to blaze through these problems. So I'm going to show you. I'm going to make a little table. 2 values are enough, 3 values even better. So check it out. If I know that x is -1, that's going to be -1 is 1, 2 plus 1 is 3. When x is 0, that's going to be anything to the 0th power is 1, 1 plus 1 is 2. And last but not least, when x is 1, 2 to the -1 power is 1/2 plus 1 is 1.5 or 3/2. Now I got 3 amazing points. I can check everything. Let's go. -1, 3, boom. 0, 2, boom. It's probably this one. And 1, 1.5. A is the winner. I don't even have to worry about memorizing transformations, that's a flip over the y-axis, a move up by 1. Doesn't matter. I got this great system. Now we're going to look at this one. See, right here, 0, 2 is fails. 0, 2 isn't there, out. This one, 0, 2 is there, but then what do we have? -1, 3, that's out, right? -1, 1. And then this one, yeah, no -1, 3. There is 0, 2, and there's 1, 1. That's not a point. So that's how you do it. Number 14. The complete graph of the function f is shown in the xy plane. What is the y-intercept of the graph of this guy? All right, so this is a tricky one because you might be like, hey, what's the y-intercept? Oh, sweet, it's 2. But what did they say? They said this is f, right? This whole thing is f. We want to know f of x plus 2. So this is nice because what is a transformation when you have it written in this format? What type of transformation is that? Plus 2. That means we're going 2 to the left. It's counterintuitive because, but on the inside, whatever those transformations are to the x value, here, let me draw this out a little bit. You go 2 to the left. So check it out. I'm just going to go 1, 2, and boom. Now they said, what is the y-intercept of this transform graph? It's 0, 3. A is the winner. Done. Oh, what did I do? There we go. Okay. Rectangular prism A is similar to rectangular prism B. What is a rectangular prism? It's like a little box or ice cube, something like that. So they're similar, right? So it means they look the same, but maybe one's bigger than the other. Where the longest side of rectangular prism A, oh no, yeah, A is the big dog. Here we go. B is the little dog. The longest side of rectangular prism A corresponds to the longest side of B, right? They're similar. That makes sense. We got the volumes. The length of the longest side of rectangular prism A is 6. So just the way we drew it, that would be 6, right? What is the length of the longest side of B? The first thing that people might do in this question is be like, oh, look at that. It's 8 to 1, right? So A is 8 times bigger than B, so it's probably divided by 8, 6 over 8, or 3/4, boom, done, but not so fast. That's not how it works because this is volume, and we're talking about side length. All right. So when we talk about volume, area, and side length, if the ratio of the volume is 8 to 1, right, we go back to get the side length. This is the ratio of the side lengths cubed. So we take the cube root of both of these, and we get a cube root of 8 is 2. It's actually going to be a 2 to 1 ratio. The area, not that it matters, is going to be this squared, which would be a 4 to 1 ratio. So if it's a 2 to 1 ratio, I know this side is 6. This side has got to be 3. Boom, done. The other way that you could have pieced this together is you know that the volume is 96. If the longest side is 6, the only other integer values that are going to be nice and are going to work here is 4 by 4, right? So 6 by 4 by 4, okay? And that's going to give you 96. So then when you think about like the side lengths here to have a relationship, right? You don't have many options to have whole numbers, but if you divide everything by 2, you get 3 by 2 by 2. Then you can check it. 2 times 2 times 3, that is indeed 12. So a 1 to 2 ratio for the side lengths, 1 to 8 ratio for the volume, which means 3 is the winner. Done. All right, 19. A forest contains different species of trees. So this is on the calculator section now. Let T represent the total number of trees in the forest. H represent the number of hickory trees, and K represent the number of oak trees. Okay, T is okay. If a tree is selected at random from the forest, which represents the probability of selecting a tree that is neither hickory nor oak. So neither hickory nor oak would be the total trees minus hickory minus oak, right? No particular order. I could do minus, other order. But then the probability is that it's this many trees that are not that divided by the total number of trees. That's it. You see how I pieced it together? I didn't even look at the answer choices. I pieced it together. Then I look at the answer choices. B is the winner. Done. 20. In the XY plane shown, the quadrants are labeled 1, 2, 3, 4, blah, blah, blah. This is the graph of this where H and K are positive constants of parabola. By the way, when H and K are positive, we're going to talk about what that means in a second. Which quadrant is the vertex? Now, the reason why I chose this problem is because it's very abstract. The fact that H is positive and K is positive means that I could kind of replace them with just like random numbers. And I'm going to do that for illustration purposes. So what does this mean? This would mean that since these are both positive, 3 and 2, fine, my vertex would be -3, +2, because the vertex is always the x value, that number in there flipped, and then the y value as is. Where's -3, 2? -3, +2. Quadrant 2. Do I care that there's a minus in front? No. That just means it's going down versus up. But that's not what they're asking about. Asking about the vertex. Vertex is in quadrant 2. Boom, done. What's up from Azerbaijan? I hope I'm pronouncing that right. And what's up from the Ivory Coast? That's legend. All right. Hey, thank you, Toe. Much appreciated. All right. In the figure shown, GE and DH intersect the point F, which the following additional statements are sufficient to prove triangle DEF is similar to HGF. Now, here's the dealio. We know that we've got vertical angles here. If you remember vertical angles, lines go like this, like this. The angles that are formed are always equal. These angles are also equal, the opposite angles, but it doesn't matter. Okay, so we know they intersect, and we're trying to prove that these guys are similar. Here's the dealio. We need with one set of angles that are, wait, is there anything else that we know? They intersect at point F. Which of the following additional statements are sufficient? Yeah, we don't know anything else. So if we don't know that any, because I was trying to see if it said parallel or something. Now, it does here. So we need one way to prove similarity. You can do angle, angle. That's the easiest, most common way. You can do side, side, and angle, side, angle. But what that means is the sides are not congruent in these. They're proportionate. Let's talk about it. So let's look at option 2 first. If DE is parallel to HG, these lines are parallel. I can get my other angles because if they're parallel, this angle is congruent to this angle because they're alternate interior angles. That proves by angle, angle. So 2 is sufficient. So A is out. And what is D? D is out. So it's either this one. Now let's look at option choice A. The length of DE, which is this length, is 1/3 the length of HG. So 1/3. So let's say this is X. This is 3X or something, right? And let's reset this. 1 is sufficient and 2. Okay, so let's reset. So now I have an angle, right? I have these two angles and I have a proportionate side, but I don't have, again, it's got to be angle, side, angle, or side, angle, side. I don't have a second side that's proportionate, and the angle's got to be in between those. So 1 is not going to be sufficient. So I think that's all there is, right? 2 is sufficient, 1 is not. Let me make sure I didn't misread anything. Which of the following statements? Yeah, that's it. So we're going to go with option B. 2 is sufficient, 1 is not. Boom, done. 29. Which of the following equivalent forms? Hey, what's up from Palestine? All right, which of the following equivalent forms of the given function f displays as the base or coefficient, the y coordinate of the y-intercept? All right, so you might look at this and be like, I have no clue what they're talking about. But the beauty of something when they're asking for a y-intercept is we can always find the y-intercept super easily by plugging 0 in for x. So if I plug 0 in for x, I get 3 to the negative 2 times 0 plus 1. 0 plus 1 is 1. 3 to the negative 2 times 1 becomes 3 to the negative 2, which is 1 over 3 squared, which is 1/9. Great. So now I know my y-intercept is 1/9. Where do I see 1/9 down here in any of these equations? Only one spot. 1/9 is the coefficient. That's the y-intercept. Boom, done. That's all they're asking. All right, 37. What is the perimeter of an equilateral triangle? Oops. Let me move this. With a height of 5√3. Okay, so there's a couple things that we need to know here. What is a height of a triangle, right? It's if we take the vertex and go straight down, make a right angle, there's our height. And we want the perimeter. So there's a couple ways you can do this. You might be able to figure out what the perimeter is from the area of an equilateral triangle formula, but let's not even go there. If this is an equilateral triangle with that nice height drawn straight down, this angle is 60. Guess what? I'm splitting that angle of 60 into 30. What do I have? 30, 60, 90 right triangle. This is the long leg. That means the short leg is this divided by rad 3, which is 5. And the big dog, the hypotenuse, that's double the little leg, which is 10. Since it's equilateral, all three sides are 10. The perimeter is 30. Done. Okay. Somebody's asking the question while I go to the next test, how many minutes should I spend, or how much time should I spend on the hardest questions? Here's the nice thing. The hardest questions are kind of at the end of the test, end of the no calculator, end of the calculator. So I would say it's not about that. You're going to get there with what you get time-wise, and that's it. And you're going to allocate that time accordingly. The reason why I say it like that is because time is really, removing time as an obstacle is really about practicing and putting in the work, finding your rhythm. When you find your rhythm and you do the requisite practice, it's going to happen organically. And if you don't finish a hard question, that's better than not finishing a medium or an easy question. All right, here we go. The graph shown models the height, y, and feet of a volleyball X seconds after it was hit by a player. Which equation represents the relationship between height of the volleyball and the time since the volleyball was hit? All right, what are they asking? They're asking to come up with the correct quadratic that models this correctly. So I'm going to look at it a couple different ways. Number one, I got a y-intercept of 5, meaning if I plug 0 in for these equations, I should get 5. Well, let's see. That's not going to happen with any, wait. That looks like it's going to happen for, this is a no calculator, so it's definitely not going to happen for B. It's definitely not. It might happen for this. I don't know what 0.86 squared is times negative. No, yeah, it's going to be negative. So it's not going to happen for C. And these two, it might happen. Let's just assume it happens for D. Now let's look at the vertex. The vertex are very interesting because this is actually in vertex form. And this shows me the correct vertex of 0.25, comma 6. So I'm leaning heavily towards D. But we can just double check by plugging in 0.25 in for this and seeing if we get 6. So I plug 0.25 in. 0.25 is 1/4 squared is 1/16. 1/16 times negative 16 is negative 1. Plus 5 would give me 4. So this will give me a vertex of, or a value, not even necessarily vertex, of 0.25 comma 4, which is wrong. D is the winner. Done. 13. Trapezoid A and B are similar. The length of each side trapezoid A is 8 times the length of the corresponding side of trapezoid B. 8x and x. The area of trapezoid A is how many times as large as trapezoid B. This again goes back to the idea of similar shapes. If we have a ratio, it's glitching, hold on. If we have a ratio of side lengths of 8 to 1, to get the area, it'd be this squared, 64 to 1 squared, which is 64 to 1. And the volume would be this cube, not that it matters, but it'd be, 512, I think, to 1. So if they ask that, that'd be the answer. But here's the area. 64 is the winner. Done. 20. Points A and B lie in a circle. Let me draw a circle. A and B lie on a circle with radius, that's a B, not a D, 4. Boom and boom. Okay, and we got this, we got this. The length, 4 pi fifths of arc AB. So they're saying AB is 4 pi fifths. What fraction of the circumference is, the length 4 pi fifths of arc AB is what fraction of the circumference of the whole circle? Okay, it's pretty straightforward, but it can be confusing. This is why I chose this problem. So it's this as a fraction of the entire circumference, which is 2 pi r. 2 times pi times 4, which is 8 pi. So there we go. Now let's keep change flip. 4 pi fifths times, we're dividing by 8 pi, so it's like multiplying by 1 over 8 pi. Pi's cancel out, which is good because it's free response. We shouldn't have a pi in the final answer. Then 4 and 8 cancel out to 1 and 2. 2 times 5 is 10. So it is 1/10 of the entire circumference. Boom, done. All right, now we're on to this one, 21 and 22 on the calculator section. Bar graph summarizes total number of businesses in thousands, number of tourism-related businesses in thousands in Iceland for each of 7 years. All right. So tourism business employed 13.5 thousand or 13,500 in 2009. Boom. Which of the following is closest to the mean number of employees per tourism-related business? So it's the number of employees per. Remember what I say with rates and the word per is that's a synonym for divide. So number of employees, which is 13,500 per tourism-related businesses, which is 0.58, but that's in thousands, so that's 580. This is what you need to divide to get the answer, and that's it. This is the calculator section, so I'll go ahead and use the calculator because I don't know. Let's see what it is. 13,500 divided by 580, which is about 23. C is the winner. Done. Cool. How many distinct real solutions does this equation have? Okay. We've got this in this interesting form. I'm going to show you. So the first thing you can do is FOIL everything out, set it equal to 0, factor, solve, boom, done. The second thing you could do is you can use a little substitution, which I'm going to advocate for here because it makes it a lot easier. So I'm going to say that y equals x minus 5. Then I have y squared plus 10y plus 25. Then I can factor this really nicely, right? What is it? It's y plus 5 times y plus 5 because 5 times 5 multiplies 25 adds to 10. Boom, done. This only gives me one solution, which is -5 for y. Now, I know it's probably 1, but I'm just going to plug it in just to make sure. So then y equals -5 minus 5, which is -10. I'm sorry. What am I doing? Plugged in backwards. Y is -5. So -5 equals x minus 5. Add 5 to both sides. Boom, boom. And x equals 0. So 0 is not, it's not saying what is the solution. It says how many solutions. One solution, which is 0. If you want to double check, plug in 0. That's 25 time plus -50 is -25 plus 25 is 0. Boom, done. What's up, Will? Welcome to your first live stream. Awesome. Okay. Anyways, 28. The dot plot shows each represent data. Which of the following statements best compares the means and standard deviation? So here's the nice thing about this question. This is why I chose it. Can you calculate the mean by being 10 plus 10 plus 15 plus 15 plus 15, blah, blah, blah? Yes, you can. But the beauty of this question is the data is perfectly symmetric. Look at this nice symmetry there and here. It's perfectly symmetric. When that's the case, the middle is the mean, which means both of these have a mean of 20. So the means are equal. That means C is out, and that means D is out. Now it's a question of standard deviation. That's the spread. Again, you don't need to calculate this. You could in your calculator, but it'd be a big waste of time. Deviation is the spread. Obviously, they're distributed or spread out differently. Which one is more spread out? B. See how B is evenly spread across those, whereas A is more concentrated at 20. That means standard deviation of A is less than the standard deviation of B, and that's the winner. What's this one? Let me make sure. Standard deviation of A, no, it's not. Okay. Done. 30. The graph of f of x plus 1. This is such a sneaky problem because you might think, hey, it's the graph of f of x. No, this is the graph of f of x plus 1. So f of x is then going to be shifted down by 1 like this, just so you get an idea. And which one is that? All right, so let's see. Actually, wait, let's be more specific with our graph. So every point here, that's shifted down by 1, whatever that one is. And then that's pretty much it. Okay. So something like this. So I know that 0 should give me 1, which it does here, and 1 should give me 3, which it does not. 0 should give me 1, and 1 should give me 3. That works. 0 should give me 1. It does not. Plug in 0. That's 2 to the 0, which is 1 plus 1 is 2. And 0 should give me 1. Plug in 0. I get 3 to the 0th, which is 1 plus 2 is 3. I'm supposed to get 1. B is the winner. Boom, done. And 36, last one. In the circle shown, or last one for this test, point O is the center, and diameter UX bisects, blah, blah, blah. Diameter UX, so bisects, so that means these two sides are equal. The radius of the circle is 6. Remember, I've told you guys this. Whenever you see one of these problems, you're probably going to have to draw a radius. That's what I'm doing here. That's a value of 6. Cool. And then it says XZ is 2, filling that in for the diagram. And do we have any other information? Okay, what is the value of, oh yeah, and then it says WZ, which is this thing, is square root of X. That's the same thing as ZY, because it's bisected, so they're equal. Okay, you may not think we have enough here, but we do, because this is a radius as well. And if this is 2, this is 6 minus 2, which is 4, right? This plus this now adds up to 6. Well, look at that. We got great information because that's a right triangle. If you're not sure why, when you bisect a chord from a radius, they have to be perpendicular. But guess what? It doesn't matter, because if you don't know that, you're going to have to assume it, because there's no other way to solve this problem. So it's like, well, I could use Pythagoreans, but I don't know if it's right. Can't think of anything else. Pythag it is. All right, so I have 4 squared. And by the way, this is what we're trying to solve for here. Same as this guy, which is square root of x. So you can say 4 squared plus square root of x, because this side represents square root of x, squared equals 6 squared. That's 16. Square root of x squared is x equals 36. Subtract 16 from both sides. X equals 20. That's what they're looking for. Boom, done. All right. We're on the last test, which is October. And this is one of the most interesting tests and I took this one for real. I don't know if you guys saw my score reveal, but I did get an 800 on math. And, I cannot turn the volume up. It should be good. That's strange that the volume is not high. It should be perfect. It's like the levels are perfect on my system. So which of the following expressions is equal to the given expression? Distribute. Square root of x squared plus square root of xy. Because when you multiply, underneath the radicals multiply each other. Well, square root of x squared is just x. And then we left with radical xy, which is a, boom, done. 19, given expressions written. Okay, so this is a pretty interesting question from the no calculator. So what are they trying to find? They're trying to find the value of D. So of course you could FOIL this whole thing out, boom, boom, take forever. But that's gonna be a little bit of a waste of time. What you can realize is D is in front of the x squared. So all I care about are x squareds. This is gonna give me x to the 5th, x to the 4th, x cubed. Here's my first x squared, negative 6x squared. Then I got another one, 15x squared, and then last would be 5x. We don't care. So all I care about are these values. 15 plus negative 6 is 9x squared. So the value of D is 9. Boom, done. And Moyad, I'm right there with you. And guess what? The last one for this test is on here, and we're going to do it, and I'm going to show you how to knock it out of the park. Number 19, tables show frequencies of data values for 2 data sets. Now, this is very interesting, right? Look at the spread. This goes from 0 to 9. Everything in between is included. 4 to 13. Everything in between is included. And the frequencies match identically. This is a very weird question where the spread is exactly identical across 9 values for 2 data sets with different values, which means what? Spread is the standard deviation. The standard deviations are equivalent. This one is also complicated by the fact that they're like these weird variables. Mean is A. Standard deviation is B, right? And that's for A and B, mean and standard deviation. So this means that the standard deviation B is, and then again, same thing, mean is C, standard deviation is D. The standard deviations are equal, okay? So B equals D, out, out. And then we're talking about the mean. The beauty of this question, the nice part is we don't have to calculate the means because we can see it's the same number of everything, but these are all higher, 4, 5, 6 instead of 0, 1, 2, which means that the mean of Q, aka C, is bigger than A. So which one says C is bigger than A? B is the winner. Done. 20. The circle shown has center -1, 1 line is tangent to this circle, which that is very important. And again, same tenet holds true. Draw on that radius. At -4, at 4, -3, which of the following it also lies on line T? Well, I'd love to get an equation for line T, so let's do that. I have a point, but I don't have the slope. But the nice thing is, when you draw a radius and that touches a tangent line, it's always going to be perpendicular. So if I can get the slope of this line, this radius, where I have 2 points, I can get the slope of line T, which is really nice. So the slope of this radius is, let's do slope formula, 1 minus -3, difference of the y's over the difference of the x's, -1 minus 4. That's 4 over -5 is the slope, which means the slope of line T is the opposite reciprocal, positive 5/4. And now we can use point slope with this point to come up with the equation of the line. Y minus -3, which is y plus 3, equals the slope times x minus 4. Distribute, distribute. Y equals 5/4 x. 5/4 minus 4 times -4 is -5. And then we minus 3, and that gives us -8. So now I have a nice equation for this line. Which points lie in the line? Let's plug and chug. If I plug in 0, I get -8 out. If I plug in 3, I know I'm not going to get a whole number. If I plug in 8, I will, because 5/4 of 8, if I multiply this, divide by 4, that's 2 times 5 is 10, plus -8 is indeed 2. C is the winner. Boom, done. All right, 26. The population in millions of this place, China, Suzhou, China, can be modeled by the function, boom. All right, and this is from 1990. So 0 is 1990, 5 would be 1995, et cetera, et cetera. Which of the following equations best models the population where n represents the number of years after 1995? Okay, here's again how I'm going to break down this problem. I'm not going to try and derive the equation, nothing fancy. Instead, since I know that when this is, let's say, 5, 1.1 times 1.066 to the 5th power, okay? That's representing the population in 1995. Just like if I plugged in 0 to whatever the correct equation may be. Because it should be the same value. They're both modeling the same thing, just different starters for the n value. If I plug in 0 here, do I get this? No. I get 1.1 times 1.066 to the 0th power, out. If I plug in 0 here, do I get the same thing? No, because it'd be -5, out. If I plug in 0 here, do I get the same thing? I do, right? Because that goes to 1, and that works. If I plug in 0 here, this would disappear as 1 again, and the difference would be, this is 1.1 to the 5th power. That shouldn't be the case. So D is eliminated, C is the winner, boom, done. 29. By the way, this test had the hardest calculator section I've ever seen, so that's why most of the questions are from the calc section. A piece of paper is cut 2 times, so just to show you what they're talking about, it's like boom, boom, and resulting in 3 smaller pieces of paper and size. Then the 3 smaller pieces are stacked, so they'd be stacked like this, and then again, it's cut 2 times, boom, boom. So I have 3 pieces cut like this, And so you imagine 3 layers. So now I have 9 pieces stacked, right? So here I have 3 pieces when I cut it. Here I have 9. And then when I cut it again, well, now I'm tripling those, and that's going to be 27. Boom. All right. So we got some interesting things. This process continues until the pieces of paper are too small to cut. Which of the following functions gives the number of pieces that result after C cut? Well, we already got some good values. When we have 2 cuts, right, as we show here, we have 3 pieces of paper, okay? When we have 4 cuts, right, which is the situation here, let me write this down. We have 9 pieces of paper, so 2, 3, 4, 9. We already got 2 values. This is more than enough. If I plug in 2 here, do I get 3? Yes. If I plug in 4 here, 4 over 2 is 2, 3, and that's 3 squared is 9. Well, it looks like A is probably the winner, but let's double check. Here, if I plug in 2, I get 2 over 2, which is 1. 1 plus 1 is 2. 3 squared is 9. It's not 3. B is out. This one, I plug in 1, I'd get 9. 2, I'd get 3 to the 4th, which is 81. Definitely wrong. This one's even worse. It's too big. So A is the winner. That's how you do it. Done. Yeah, that test humbled me too, guys. By the way, I was just like, whoa, these questions are like I really had to look over things carefully. There are 640 acres in 1 square mile. All right, this is a very interesting one. The area of a forest is increasing at a rate of 1 acre per decade. Which of the following is close to the rate at which the area of the forest is increasing in square kilometers? All right. So I've seen students do this in different ways. I'm going to show you how I like to do it. So I got 1 square mile, right? So I'm going to turn that back into length, not area, because they're giving us this. Because you can't turn 1 square mile by dividing it by 0.62 or multiplying it by 0.62 either way into square kilometers. We have to do it like this. So 1 square mile is the same as, 1 kilometer is the same as 0.62 square miles. So if I want to turn a square mile, I'm sorry, why did I say square mile? This should be a mile. Excuse me, 1 second. If I want to turn a mile into a kilometer, I have to divide by 0.62. So 1 divided by 0.62. And that, 1 divided by 0.62, which is 1.61, basically. All right? So it's 1.61 kilometers by 1.61 kilometers. And now if I multiply it to get the square kilometers, right, I'm just approximating there, but if I square it, I get 2.6 kilometers squared is the same thing as a square mile, which is the same thing as 640 acres. So look at that. Now I know that 2.6 kilometers squared is 640 acres, but it's increasing at 1 acre. So I want to know what is 1 acre. So I'm going to divide both sides by 640, right? And that would be 1 acre equals this many square kilometers. Obviously, they did not, oh wait, I should have used that answer. Hold on, let me do this just to be exact. So it's that answer divided by 640, which gives us 0.004 rounds to, maybe 0.0041. D is the winner. Boom, done. 37 and 38, 2 left. Here we go. Watch how I'm gonna do this one. This is exactly how I did it on the real thing. R is 20 over 21 times T. The hardest part is done. I got my equation. The value of T is what percent greater than the value of R. Lots of different ways we can do this. I'm going to choose values. It's going to be much easier. And by the way, I think it's going to be easier. Well, actually, what's the easiest here? Yeah, let's just do this. Let's set T equal to 21. Okay, this is going to be the easiest thing because if T is 21, okay, then R would equal 20 over 21 times 21. I chose that deliberately because the denominators will cancel out and R equals 20. Now I got 2 really viable options for T and R. And it says T is what percent greater than R. Now we do our percent greater thing. So T is 1 greater than R. What percent greater than R is it? So we have to do 1, that difference, or that, how much greater it is over the original, what we're trying to measure against. So 1 out of 20 is what as a percentage? Percent formula, percent equation. Sorry, percent proportion. And that's 20x equals 100. Divide both sides by 20. X equals 5. So it's 5%. We just enter 5 in the answer sheet. Boom, done. Now we get to the crazy one. This one caused a lot of people a lot of stress, including myself, because I'd never seen anything like it. It was wild. I'm going to show you how to do it. Here we go. A and B are each greater than 0. And 4 times the square. Okay, so watch this. 4, so again, same principle as the last one. 4 times the square root of A is equal to 9 times the cube root of B. Then it says if A equals 2/3, goodbye A, because we don't need you now. We know what you are. For what value of X is A to the X? And that's where it's confusing. They keep saying A, but they already told you what A is, and you have to go back and do we do A? You know, that's the confusing part. For what value of X is 2/3 to the X equal to B? All right. So first, look, if you think about it, it's a straight up system of equations. It's not that complicated. Solve for B here, plug it in, solve for X, boom, done, right? It's just because the numbers are so weird that it's difficult. But let's do it step by step, and I'm going to show you how to do this even without a calculator. So first I want to solve for B. We're going to divide both sides by 9. So we get 4/9 times the square root of 2/3 equals the cube root of B. What you always want to think about in these rational roots, rational exponents problems, is can I get the same base? Well, 4/9 sure looks like 2/3. 4/9 is really 2/3 to the second power, right? And this square root of 2/3 is really, square root is to the 1/2 power. Well, now I got the same base. Now I can add these up. So guess what? B equals 2 plus 1/2, 2/3 to the 5/2 power. So that's pretty cool, right? Cube root of B equals that. Then I want to find B, so I'm going to do the opposite of cube rooting. I'm going to cube both sides. Cancels that out. Multiply in, and we get 2/3. 3 times 5/2 is 15/2. God, not a lot of room here, but check this out. So then, last but not least, I got 2/3 to the X power equals 2/3 to the 15th power, 15/2 power. Sorry. Well, when these are the same, get rid of them. X equals 15/2 or 7.5 for the win. Done. And that's how we're doing it. That's how we do it. So that's pretty much it, guys. So listen, I know people are asking me some questions. I really got to bounce. How did I get 1/20th? Okay, just really fast. You can choose any other numbers, right? I could have also chosen 100 and 105. That would have worked, right? 20/21 times 105 is 100. And then you get, obviously, 5 out of 100 is 100%. So, guys, I got to bounce. I got to start tutoring ASAP. So I'm going to get prepared for my tutoring appointments. Here's what I want to say to you guys. I'm going to post for this live stream ASAP. It's probably going to be starting at 8 a.m. tomorrow morning PST. If you can join, please do. If you can watch it later or the morning of, definitely do. And that's that. It's going to be amazing. If you can give this video a like, I'd much appreciate it. If you want to subscribe and check out more from the Scalar Learning channel, make sure to do that. If you want to check out our video course, you can buy it today. It's only $15 a month and cancel it right away. You still get access for a full month. You can do that. It's in the description link below. Last but not least, join our Discord server. I always blast out to my Discord server when I'm about to stream or post a video. So it's free. You can meet other people. Amazing. Build a study group. Do your thing. Rock out. That's it, guys. Thank you so much for joining, and I wish you the best of luck on Saturday. Thank you so much, and I will see you